So this is lecture 6 in digital circuits. So in this lecture, we're going to discuss about the signed binary numbers. Now, how to represent a signed numbers. So up to now, we have seen only unsigned numbers. That is, so any number can be represented as from 0 to 1. It's like a unsigned number. So all are the positive numbers. Now, in digital circuits, I told in the previous lecture, if we want to subtract any two numbers, so that subtraction also we will do in what you call addition method only. So that will make very simple circuits or simpler methods, right? So that we need to discuss today, that is signed binary numbers. Now if you see the difference between unsigned and signed numbers, so in unsigned numbers, the magnitudes from 0 to n, so suppose 0, 1, 2, 3 are unsigned numbers, so it's like a positive numbers, right? So including 0 also. So 0 can also represent as positive 0. So it's not like it's positive. All unsigned numbers are positive numbers, that is from 0 to n. Now if we see the signed numbers, that is the positive will be represented by the positive plus 1 plus 2 plus what you call, if it is a 0 plus 0. This is a signed numbers. That means for negative numbers, to represent negative numbers, we will go with the signed numbers. So what in the decimals, so what we can represent, plus positive means plus 1 plus 2 etc. Negative means minus 1 minus 2 minus 0 and so on, right? So this is positive, this is negative numbers. So in signed numbers only. But computer doesn't understand this type of numbers, right? So it will not understand the decimal numbers. Only it will understand in digital numbers only, or digital bits. Now how to convert a positive number or signed number into in terms of digits? So that is the main concern. So that is this point. So but digital computers must represent everything in binary digits. So to represent binary digits in a signed magnitude form or signed, how to represent? Now this is the formation, that is the leftmost bit is called as sign bit, right? So leftmost bit, or we can say MSB, don't confuse with LSB, that is the least significant bit, most significant bit. This is a leftmost bit. So leftmost bit is always sign bit, right? If there is no sign, I mean this is not a signed magnitude form, or sign, it is unsigned number, so it will be simply MSB and we will get the magnitude according to that. So this is a magnitude. Suppose example, suppose if I want to represent plus 7. Now how to represent plus 7? We know that 7 is binary representation is 111. Now to represent plus, so we will add sign bit here, right? This is a sign bit we need to add. Or simply if there is no, this is unsigned number, so simply it is 7 only, right? So I hope you got the concept. Now how to represent the positive and negative? So in digitals, always the positive represents the leftmost bit should be 0. If it is a negative number, the leftmost bit should be 1. So this is a convention we need to follow, right? So for positive, so the leftmost bit should be 0. For negative, the leftmost bit should be 1. So if this is a plus 1, so what is this leftmost bit should be 0. If it is a minus 7, so leftmost would be 1 and the remaining all ones. But if it is an unsigned number, right? So what is this one? Simply 7. This is plus 7 means this is plus, yeah. Now this is if it is an unsigned number, if it is unsigned number, the representation is 15. If it is a signed number, the representation is minus 7. So that is a difference. Unsigned means everything will be magnitude. If it is a signed number, this bit will be sign bit. So if it is a 1, minus. If it is a 0, plus. That's it, right? So now we'll see what are the types of this one. Whatever we discussed, there is a signed magnitude convention. Then we can represent negative numbers using 1's complement representation and 2's complement representations. Now we'll see one by one. Signed magnitude representation is the first or LSB bit will be sign bit, then remaining with magnitude, right? Magnitude. So same as we discussed. So suppose if I want to represent plus 15, so 15 we can represent by 4 bits, that is 1 1 1, and plus represents 1 bit, that is 0. So to represent plus 15 we require 5 bits, right? So that is the one. If we want to represent minus 15, how to represent? The first will be 1, remaining also will be same, 1 1 1, only sign bit will change. So this will represent again 5 bits, right? This is the signed magnitude representation. Now to represent the negative number in ones complement, so what is the method or procedure? So very simple, I'll make like that. See, what we need to do is first find the signed number representation or signed magnitude representation, then convert or find ones complement of the this form of signed magnitude representation, right? So how? Suppose we just seen plus 7 can be represented by 0 1 1. Now always first we need to find the 7. What is the 1? 1 1. Now plus 7 means it will include 0. So ones complement of this number will be represented minus 7. So ones complement of this number is what? So 0 replaced by 1, 1 replaced by 0. So that will become 1 0 0. So minus 7 in ones complement will be represented by 1 0 0. Right? Similarly, any what do you call negative number can be represented by like this only. So suppose if I want to represent minus 15. So first step is, what is a 15 equivalent binary number? So 15 means 4 ones. Now first we will find the positive, that is we will add 0, 4 ones. Now to find minus 15, just take the ones complement of this number. So what is the ones complement of this number? Simply 0 replaced by 1, 1 replaced by zeros. That is the one, right? So what is the conclusion in this is, if it is a ones complement representation or signed magnitude form, always this negative, if it is a negative number, the leftmost bit always will be 1. So this is the one. See, whatever we discussed in the previous, this one is also minus 7 means always the signed bit will be 1. So that is the conclusion. So if in the exam, suppose he asks, it says in the signed magnitude form or ones complement representation form or two's complement, if the leftmost bit is 1, so it is a negative number. Now you can easily tell two's complement representation is what. So what is the first step? So step 1, find the positive number. Find positive number in signed magnitude form. Second step is find two's complement of step 1 result. So that will represent a negative number in this one. Now suppose if I want to find plus 7. Now so first plus 7 means first will be 0, remaining 3 will be 1. Now if I want to represent minus 7, so 2's complement of this number. Every digit, the first non-zero digit, subtract from 2. So 2 minus 1, 1. 1 minus 1, 0. 1 minus 1, 0. 1 minus 0, 1. This is the minus 7 representation in 2's complement form. Now, or simply minus 7, we got 1 0 0. 1's complement, right? This is the 1's complement. Now, if I add 1, so I'll get 2's complement. So, this is the representation of minus 7 in 2's complement representation. Similarly, plus 13. So, what is the plus 13 first? So, 0, 1 1, 0 1. If I want to represent minus 15, what we need to do? We need to take the 2's complement of this number. So first non-zero digit from 2. 2 minus 1, 1. Next all are from 1. So 1 minus 0, 1. 1 minus 1, 0. 1 minus 1, 0. 1 minus 0, 1. So this is the minus 13. So 1 0 0 1 1. So this is the representation of minus 13. Right? So this is about the signed representation. So binary numbers in signed magnitude forms, right? So either plus 7, minus 7, everything is we can represent in signed magnitude forms or signed numbers, right? Now we'll see. So what is the ranges of these binary numbers? Now we are representing using the signed numbers. So for n bit, so what is the maximum possible numbers we can represent? So that is the ranges we need to find. Suppose this is the unsigned number. So for n bit, so what is the range we can represent? So from 0 to 2 power n minus 1. This we know. If n is equal to 3, so 2 cube means 8. 8 minus 1, 7. So for n is equal to 3, or n is equal to 4 and so on. So we can represent from 0 to 2 power n minus 1. That is something like 0 to r minus 1. R is a base. Now, if it is a signed number, so we have three forms: signed magnitude form, 1's complement form, 2's complement form. If it is a signed magnitude form, so range will be, so this is the range from minus 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1, right? So that is if n is equal to 3. So n is equal to 3 means 3 minus 1, 2. So I'll take example. Suppose n is equal to 3. So total bits is 3. So n minus 3 means, n minus 1 means 2. 2 square means 4. 4 minus 1, 3. So the range will be minus 3 to, so same, right? 2 power n minus 1 minus 1. So plus 3. So we can represent from minus 3 to plus 3 only. If it is a bits, number of bits is 3. If number of bits are 4, so how can you represent? Minus 7 to plus 7 and so on. That is, it is including minus 3, minus 2, minus 1, 0, minus 0, plus 1, plus 2, plus 3. Now, similarly, for using 1's complement, so we can represent the range is same as this one. So 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1. Again same. So if n is equal to 3, I will take n is equal to 4 in this case. If n is equal to 4, so the representation will be minus 7 to plus 7, right? So if it is 2's complement form, so generally we the negative numbers will be represented in 2's complement form. So there is an advantage of this number. So generally we are not having minus 0, right? So 0 means, so it's a plus 0 or simply 0. So it cannot be minus 0 or plus 0. So always it should be plus 0. There should not be any minus 0. But using this signed and 1's complement form, so we are getting minus 0. So in 2's complement form, we will not get minus 0. So that also we'll see. So range is minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. So this is the representation, that is minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. Suppose if n is equal to 3, so the total number of bits is 3. So 3 means 2 power n minus 1. So 3 minus 1, 2. So minus 4. So 2 square means minus 4 to plus 3. So we'll get extra negative number in this case. See, minus 3 to plus 3, minus 7 to plus 7. Here, so compared to this one and this one, so we're getting extra negative number. So that means here we will not get minus 0. So that also we'll see, right? So this is the ranges of this signed numbers, right? Ranges of binary numbers for unsigned then signed. So in 3 signed magnitude forms, so we'll get minus of 2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1 for these two cases. This one is different, that is minus of 2 power n minus 1. So these three are important, just we need to remember, right? One example, that suppose it is in 1's complement form. So what is the equivalent magnitude or equivalent decimal number with including minus or sign bit? The moment it is already in 1's complement form, so there is a negative number because the first bit is 1. Now how to find the magnitude? Now there is a procedure, that is the first bit is a negative. So minus of 2 power n minus 1 minus 1. This is the first number, plus say 0, 1, 2, 3 and so on, right? So 0, 1, 2, 3. So 3 means, so 3 minus 1, so it will get value, plus 0 into 2 power n minus 2 plus and so on, right? Now, so what is this? N is equal to 4. So minus of 2 power 4 minus 1 minus 1 plus the, or we can say simply 0, 1, 2, 3. So directly 2 cube minus 1 plus 2 square into 0 plus 2 power 1 into 1 plus 0 into 2 power 0. So what is this value? 2 power 4 minus 1 is 2 cube. So 2 cube means 8. 8 minus 1 minus 7 plus this is 0. This is plus 2 plus 0. So what is this one? So minus 7 plus 2. The value is minus 5. Right? So see, for 4 bit we can represent minus 5 in 1's complement form that we have seen. So R will go with the standard procedure. So plus 5 means how much? 0 1 0 1. So if I find 1's complements, what we will get? 1 0 replaced by 1, 1 replaced by 0, 0 replaced by 1, 0. So 1 0 1 0. Is it right? Yes. Now how to find the magnitude of this one? We can find like this. The first bit is minus of 2 power n minus 1 minus 1 into 1, not only 1, minus of the magnitude is into 1. So we'll get this one. Then remaining. So if it is 0 1 2 3, so directly I can write minus of 2 cube minus 1 into 1 plus 0 into 2 square plus 1 into 2 power 1 plus 0 into 2 power 0, etc. Now if it is a 2's complement form, suppose same example, suppose it is in 2's complement form. 2's complement form. So suppose 1 0 1 0. So the first bit is negative, so minus of 2 power n minus 1. No minus 1, so into 1 plus and so on. So 0 1 2 3. So that is minus of 2 cube into 1 plus 0 into 2 square plus 1 into 2 power 1 plus 0 into 2 power 0. So minus 2 cube means minus side, plus 0 plus 2 plus 0. So what is this? Minus 6. So same 1 0 1 0 will represent minus 6 in 2's complement form. Now we'll see plus 6 0 1 1 0 minus 6 into 2's complement. So first non-zero, so 0 means 0 only, first non-zero digit from 2. So 2 minus 1 1, 1 minus 1 0, 0 1 minus 0 1. See, minus 6 into 2's complement will be represented by 1 0 1 0. So I think you will remember this one. So if it is a 2's complement, minus of 2 power n minus 1 into 1. N is equal to the number of bits, that is 1 2 3 4 etc. Or simply this is a 2 cube, right? So we can directly write the first leftmost bit. If we start from 0 to like this, so we'll get directly 2 power cube. Or count number of bits, that is 1 2 3 4. So n is equal to 4. So 4 minus 1. That's it. Remaining will be like this. So n minus 2, n minus 3 and so on. Right? So this is about this one. We will see the ranges of this, how to represent the, suppose. Now we will see the decimal value and equivalent signed magnitude forms, right? Signed magnitude form, signed 1's complement form, signed 2's complement form. Now how to represent signed magnitude form? Now how to represent 3 in how many bits I can represent? 2 bits I can represent. Now this is unsigned. Now if I add plus, so what we need to do? Signed magnitude form, we need to add one extra bit, which is positive means 0. Now similarly 1 0, that is 2. So plus means 0, 1, that is 0 1, positive means 0, 0. So 0 0, positive means 0. Now minus 0 means the sign bit will be 1, the remaining is 0. Minus 1, 1 0 1, 1 1 0. So minus 2, right? So 3 means 1 1. So I cannot represent minus 4 in using 3 bits. So if I want to represent minus 4, I need 4 bits in signed magnitude form. Similarly, 1's complement form. Now remember, for positive numbers, signed magnitude form equal to the unsigned ones and signed 2's. So whatever here, so we can write directly 0 1 1 0 1 1. Similarly 0 1 0 0 1 0. Positive numbers all are equal only. 0 0 1 0 0 1. So positive. Now positive 0 means we will get same 0 0 0 0 0 0. Now see, to represent negative number, what we need to do? So what we need to do, we take the complement of the positive 0. So positive 0, if I take complement, 1's complement, all will become 1 1 1. Right? Yes or no? So if I take, see, this is a signed magnitude form plus 0. If I take complement of this number, I will get triple 1. Similarly, if I take complement of this number, so what is this one? All triple 1. Yes or no? So triple 1 is not possible in this one, right? Because that will be represented by another number. So minus 0 is not possible in signed 2's complement form. So that is, so 1's complement means this one. If I add 1, so what I will get? 1 means, what is this? 1 plus 1 0. So here get carry 1 plus 1 0. Again carry, you will get 1 plus 1 0. So you will get 0 0 0 only. So anyway already we represented positive 0, so it is not possible. Yes or no? see, positive 0, we got all zeros. So for negative 0 in 1's complement, we got 1. This is 1's complement. If it is a 2's complement, so what is this one? We need to add plus 1 here. So 1 plus 1, 2 will get 0, 1. Again 1 plus 1, 0. Again 1 plus 1, 0. Carry discarded. So this is 0, 0, 0. So already we represented. So minus 0 is not possible in signed 2's complement form. Now, then minus 1, how to represent? So plus 1 I will take, this is a plus 1, take 1's complement. So double 1, 0, double 1, 0, 1, 1, 0. Now to get in 2's complement, what we need to do? Add plus 1 here. So plus 1 means I will get triple 1. Now again minus 2. So minus 2 means what? Take plus 2, take 1's complement. So 1, 0, 1. Yes or no? So if I want a 2's complement, what we need to do? We need to add plus 1, right? So 1, 0, 1. If I add 1, 1 plus 1, 0. This is the 1, 1, 1, right? So what is the 2's complement? 1, 1, 0 for minus 2. Last one, minus 3. Plus 3 means 0, double 1. So 1, 0, 0. In this, sign 1's complement. If I want minus 3 in 2's complement, just add plus 1. What is this? 1, 0, 1. Now minus 4 is possible in these two cases? Not possible. But in this case, it is possible. Now if you see, carefully observe, 0, double 1, 0, 1, 0, 0, 0, 1, triple 0. Everything is there in this. One missing, that is called 1, 0, 0. So this is the minus 4 representation in this 2's complement form. That is, if I find the equivalent decimal number for this ones, I can get easily. So if I want to find this decimal number, what is the remaining? Minus of 3 bits, right? So 2 power 3 minus 1 into 1 plus 0 plus 0. So what is this 3 power minus 1? 2. So 2 square means minus 4 plus 0 plus 0. So what is this? Minus 4. So minus 4 can be possible in signed 2's complement with the 3 bits only. So that is the advantage. See, so we can represent more plus 3 to minus 4, one bit extra, because we are not having the minus 0 in signed 2's complements. This is very, very important. So generally we represent the signed magnitude forms in signed 2's complement form, or we do the addition or subtraction using signed 2's complement, because we will not get any minus 0, right? This is about the signed binary numbers, right? I hope you get the concept, that is how to represent signed numbers. So easy procedure. Suppose if I want to represent my plus 17, what we need to do? 17, find the equivalent binary number. How to find? So 17 by 2. So 17, 2 with the divide 2. So 2 8s remainder 1, 2 4s remainder 0, 2 2s remainder 0, 2 1s remainder 0. So what is this? 1 0 0 0 1. Plus 17, what we need to do? Add 0, 1 0 0 1. Now to find minus 17, what we need to do? If it is a signed magnitude form, just add 1. So 1 0 0 1. If it is 1's complement form, what we need to do? Take 1's complement of this number, 1 0 1 1 0. If it is a 2's complement form, what do we need to do? Just add 1, 1 1 1 1 0 1. So 1's complement form, 2's complement form, signed magnitude form, right? So this is about this one, the signed binary numbers, right? The next lecture we'll solve some more problems using this complements method.